All right, so for this first problem here, we want to look at the transformation, and we've got a +1 on the inside, so this is going to tell us to go left 1 because it's on the inside and added, so that will tell us to go left 1. The -2 on the outside will tell us to go down 2 because it's being subtracted. So inside opposite, outside down. Since we're plussing and minusing, we are adding and subtracting. So we're going to take each point here on our original graph, -4, 0, we'll start with and move it left 1 and down 2. So we'll start at -4, 0, and then we'll move that left 1 and down 2, and we'll end right here. And then we'll take the point -2, -2 from our original graph here. So we're taking these 2 points, and we'll move it left 1 down 2. And then we'll take the point 0, 0, move it left 1 down 2. Take the point 2, 2, move it left 1 down 2. And then take the point 4, 0, and move it left 1 down 2. So this is the resulting graph. All right, for this next one here, the negative in front talks about reflections. So since the negative is in front, this is going to be a reflection over the x-axis. And the +1 will tell us to go up 1 because it's on the outside. So, and just kind of to help you understand why this is a reflection over the x-axis, remember when the negative is on the outside, we're going to change the y value. So if we take the point like -2, -2, and we change the y value sign, that will become -2, 2. So that point is going to start at -2, -2, and go up to -2, 2, so it reflects over the x-axis. So we change the y value and reflect over the x-axis. But then we also need to go up 1, so then we'll go up 1. Now let's do the point -4, 0. The y value is 0, so when we reflect over the x-axis, it's not going to move because you can't change the sign of 0. So we'll stay there, but then we'll go up 1. Then we'll do the point 0, 0 next. Can't change the sign of the y value because it's just 0. So then you will just move it up 1. And then we'll take the point 2, 2, change the y value. So 2, 2 will go to -2. So it starts at 2, 2, and then goes to -2, so it reflects over the x-axis. And then we will move it up 1. And then we'll take the 4, 0. It's not going to go anywhere with the reflection because the y value is 0. It can't change signs, and so then it will just move up 1. So this should be the resulting graph here. All right, for this next one, the 2 in the front, because it's being multiplied, this is going to be about a stretch or compression. It's on the outside, so it's going to be vertical. And because it's bigger than 1, it's going to be a vertical stretch of 2. The +2 on the inside is going to tell us to go left 2. And the -1 will tell us to go down 1. So first, let's talk about the vertical stretch. So first, we'll take a point like -4, 0. And if I do the vertical stretch on this one, I'm going to multiply the y value by 2, right? So vertical stretch means the y value gets multiplied by 2. But that's just going to be 0 times 2, which is just going to be 0. So that's not going to change that point. So it's going to stay -4, 0. But then I'm going to move it left 2 and down 1. So now let's take the point -2, -2. When I do a vertical stretch on this, I'm going to multiply the y value by -2. So, I'm sorry, by 2, not -2, just 2 because it's a vertical stretch of 2. So that will be -4. So I'll go over to -2, -4. But then I still need to move left 2 and down 1. Then I'll take the point 0, 0. When I do a vertical stretch, multiply the 0 by 2, and it's just going to stay 0, so it will stay in the same spot. But then I need to go left 2 and down 1. Take the point 2, 2 with the vertical stretch, multiply the y value by 2, so that'll be 2, 4 now. And then we still need to go left 2, down 1. And then lastly, we'll take the point 4, 0. Vertical stretch is not going to change that because we'll multiply the y value by 2, and that will stay 0, so that'll stay 4, 0, but then we need to move it left 2 and down 1. So the green dots are just the vertical stretch, and then we still have to move it left 2 and down 1. So that's my final answer. All right, for these problems here, we have to, in the bottom here, we need to use the parent function because we aren't given a graph. So we have to graph the graph that we need to start with, okay? So we're gonna write down the parent function and describe it in words. So here you can see the squared. That tells us the parent function is x squared. And then the minus 2 tells us that we're going to go right 2, because it's opposite inside. And up 1. Okay, so we start by graphing the parent function. This is just what we have to have memorized. So we're going to graph y equals x squared. It looks like this. And it goes through 2 points, 0, 0, and 1, 1. Those are important points. And so then this one we can probably just move it because we're doing right 2, up 1, no stretches. So we can probably just move it. So we'll take each point, move it right 2, and up 1. So we'll take this point first, move it right 2, up 1. And then this point next, right 2, up 1. And we have our answer. So this is the answer right here. This next one here, our parent function is still y equals x squared. You can see that with the square right here. That will be our parent function. The 2 in the front, that's a 2 outside, so that will be vertical. And because it's bigger than 1, it's going to be a stretch of 2. Multiply the y values by 2, and then we'll go right 2. Because of this minus 2. So we'll start by graphing the parent function again. Same parent function, y equals x squared. 2 important points are 0, 0, and 1, 1. Now I'm actually going to take these 2 points and move them with the vertical stretch first. So 0, 0, when we do a vertical stretch, we're going to multiply the y value by 2. But that's not going to change it, so it will just be 0, 0. So that's going to stay after the vertical stretch. And then, so this will just be the vertical stretch. And then we'll move it, so it'll stay, and then it'll move right 2. So this will be our new bottom of our graph. Then the point 1, 1, which is this point right here. This point will be, if I do a vertical stretch, I'm going to multiply the y value by 2. So now this will be 1, 2. So I can go to 1, 2 on the graph. And then I need to move it right 2. So 1, 2. So first I went to 1, 2, and then moved it right 2, because I have to do the second part. So then this will be the graph of my answer. All right, for number 6 here, my parent function is going to be the square root. The negative in the front is going to tell me to reflect over the x-axis. We'll change the y values, so that will reflect over the x. It's on the outside. So we'll change the y values and move it over the x-axis. And then the plus 2 inside will tell me to go left 2. So we'll start by graphing our parent function. This time our parent function is the square root function. It looks like this, and it also goes through 0, 0, and 1, 1. Now when we reflect over the x-axis, we'll take the 0, 0, and we'll change the y value. But 0, 0 is going to stay because you can't change the sign of 0. So that will stay at 0, 0 for the reflection over the x-axis, but then we need to move it left 2. So that'll be our new first point. 0, 0 will move there. And then 1, 1, when we do our reflection, we're going to change the y value. So it'll be 1, negative 1. So it's going to reflect over the x-axis and come down right here. But that's just the reflection, so then we need to move left 2. So then we'll move it left 2. So now because we reflected this over the x-axis, it's going to be upside down, right? So we reflected it over the x-axis, and we need those 2 points to be clearly identified. Okay, problem number 7 here. Our parent function is y equals the square root of x. The 1/2 in front will be about vertical, but since it's less than 1, this is now going to be a vertical compression of 1/2. And then the -1 will tell us to go down 1. So we'll start by drawing our parent function again, the square root function. So that's going to look like this, same one as last time, 0, 0, and 1, 1. Let's start with the vertical compression. Actually, here, hold on. So if we take the point 0, 0, which is at the origin, and we do the vertical compression, we're going to multiply the y value by 1/2, but that's not going to change anything. That's going to stay at 0, 0, and then we'll move it down 1. So this will be our new 0, 0. The point 1, 1, though, which is this point right here, okay, that when we do our vertical compression, we're going to multiply the y value by 1/2, or that's the same thing as dividing by 2. So we can either multiply y by 1/2 or divide by 2. So this will be 1.5 or 1/1/2. And then, so if we go to that part on the graph, it's kind of tight here. It'll be at 1/1/2, which will be right here. And then we'll have to go down 1. So that will be right here. So that's kind of weird looking. And that's kind of hard. That point's hard. So another option on this one is to pick another point on this function instead of using 1, 1. Sometimes when it gets too small, that can be easier to do. And another point on this graph is 4, 2, because if you plug in 4 for x and you take the square root of that, you get 2 for the y value. So the point 4, 2 is also on this function. So if we wanted to move that one instead, multiply the y value by 1/2 or divide by 2, we'll end up getting 4, 1. So we could go to that point, 4, 1, and then move it down 1, and it would end up here. So either one of these three, any two of these 3 points would be okay. Any two of those 3. All right, for number 8, our parent function is y equals x cubed now. And this is just going to be a reflection over the y-axis, because the negative is inside now, so it will change the x values, and so we will reflect over the y-axis. And that's the only transformation. So first we'll draw the parent function. X cubed is our squiggle, and it goes through 0, 0, and 1, 1 as well, so those are our 2 important points. And when we reflect over the y-axis, remember 0, 0 is just going to stay 0, 0, so we're changing the x values, right, when we reflect over the y-axis. That's going to stay the same, so 0, 0 will stay in the same spot. But then 1, 1, when we reflect over the y-axis, we'll change the value of the x, right? So that will become negative 1, 1. So 1, 1, which originally was right here, will now be at 1, negative 1, right here. So we've flipped this part upside down. And then the same thing happens, so like this point right here, it moves to the other side, right? So now this is going to reflect up this way. So this is our answer here. And as long as we have those 2 points marked, then we're good to go. And you might notice this is the same exact thing that would happen if you reflected over the x-axis. So that's pretty cool, right? So if you reflected over the x-axis, you would end up with the exact same picture. So with the cubic, that's the same. Okie dokie. So now for this next one, our parent function again is y equals x cubed. But now we're going to go right 4 and up 1. So we'll start by drawing our cubic function. Parent function. It goes through 0, 0, and 1, 1. We'll move each point right 4 and up 1. So I'll start with this one, right 4, up 1. Next one, right 4, up 1. And so our cubic function will look like this. And this will be our answer. All right, for number 10. Our parent function here is the absolute value. And this will be left 3 and down 2. So we'll start by drawing the graph of our parent function. That's the absolute value, so that's our v. And it also goes through 1, 1. And now we're going to move everything left 3, down 1. So I'll start with this point. Oh, down 2, sorry. And then this point. I went way too far. Okay, let's try this again. So we'll move left 3, down 2. So 1, 2, 3, down 2. And then this one, 1, 2, 3, down 2. So this will be our v now. And that's our answer. All right, for number 11 here, our parent function again is the absolute value function. Now we have a negative in front, so that's going to be a reflection. It's going to change our y values because it's outside, so it'll be a reflection over the x-axis. Because we're going to change the y values, that'll reflect over x. And the plus 4 will mean left 4, and the plus 1 will be up 1. So we'll start by drawing our parent function, the absolute value again. Goes through 0, 0, and 1, 1. We'll start by reflecting over the x. So when we reflect over x, our points, we change the y values. So 0, 0, when we do our reflection, the y value won't change, so it will stay in the same spot. But then we still need to go left 4, up 1. So first it will stay in the same spot with the reflection, and then left 4, up 1. Then we'll take the next point here, 1, 1. We'll do the reflection first. So that's going to be over the x-axis. So we're going to change the y value, so it'll be 1, negative 1. So that'll be now here. So we reflect over the x-axis, and then we'll move left 4, up 1. So we'll move left 1, 2, 3, 4, up 1. And remember, we reflected, this was now our top, and this is the bottom. We reflected over the x-axis, so this is now upside down. Because the first thing we did was reflected everything over the x-axis. All right, last graphing one. This one here, my parent function, is a weird one. We haven't seen too much, the cube root. The negative in the front is going to be a reflection over the x-axis. We'll change the y values. And the plus 3 inside will tell us to go left 3. Oh, but we forgot about the 2. Sorry, not yet. Forgot about the 2 in front. We still have a 2 out here. So this 2 in front, right, is going to be a stretch or compression vertically because it's on the outside. Because it's bigger than 1, it will be a stretch. And then we'll go left 3. Okay, so let's take our graph and draw our cubic root. This is kind of like the cubic function, but it's on its side. So it still goes through 0, 0, and 1, 1. And it's still a squiggle, but it's like a horizontal squiggle. The cube is the vertical squiggle like that. That's x cubed. Okay, so first let's take the point 0, 0. When we reflect over the x, we're going to change the y value. So that's going to stay the same with 0, 0. And then with a vertical stretch, we'll multiply the y value by 2, but that's going to still stay 0, 0. So after the reflect over x and the vertical stretch, this point is still in the same spot, and then we'll just move it left 3. So for that last thing, we'll move it left 3. Then let's take 1, 1, reflect over the x-axis, so we'll change the y value, so that will become a -1. And then we'll do our vertical stretch. That will multiply the y value by 2. So that'll be 1, -2. So let's go find that point. So the point that starts right here at 1, 1, it's going to first reflect over the x-axis. So it will be here at 1, -1. Then we're going to stretch it vertically. So we're going to multiply the y value by 2. So it'll now be at 1, -2. And then we have to lastly move left 3. So now we'll move it left 3. So now it looks like this because we reflected it over the x-axis. And then we stretched it. All right, lastly, we'll do some matching here. So here, the -6 on the inside means we're going to go right 2. So that'll be B. I'm sorry, not right 2, right 6 units. I don't know where the 2 came from. This one here, the negative on the outside means we're going to change the y values. So we'll reflect over x and then go right 6. So that'll be D. Here we're just going to go left 6. So that'll be A. Here the negative on the outside, it's still on the outside, I'll change the y values, so we'll reflect over x. And then we'll go down 6. So that'll be this one down here, G. And then for 17, this outside will reflect over x again. And we'll go up 6. So that'll be G. Or I'm sorry, not G, F. Now, in case you were wondering maybe what H would look like reflected about the y-axis. So like H, if it was across the y-axis, the negative would have to be inside, and then down 6 would be a -6 on the outside. So that's what H would look like. C would be like reflect about the x-axis, so that'll be a negative in front, and then shifted left 6, so that'd be a +6 inside. And then E, I don't think we did that one either. That would be reflected across the y-axis, so that would be a negative on the inside, and then moved up 6 like that.